All right, so thanks for coming out tonight. It's an ambitious group of people that spend their evenings and personal time doing this kind of stuff, so we do appreciate your time. So we're going to jump right into this. First, a little bit about me. I've met almost everybody here and had a lot of time to do that. So my name is Darin. I've been with DASI since 1997. SOLIDWORKS had 3,000 users at that time, and as John Paulo said, we're over 3 million now. So it's been a pretty incredible journey, and the next 20 years or so should be pretty awesome as well. So I look forward to that. One of my accolades here is Model Mania is a little championship thing that we do at SOLIDWORKS World. A lot of tech guys from around the world get together and we compete. And I won the first one and in San Diego in 2008. And a few of the other guys at DASI Solutions have either won or placed in the top 3 for that as well. So it's one of the things that we are very proud of. I'm a husband and father. We've got 21 chickens. I don't live on a farm as it states there, but this is what it looks like at my place. So they're great egg layers, and it's I recommend it if you get the chance. A lot of fun. So we are going to get into, now PowerPoint's dropping out. Lovely. Everything's having fun today. We are going to get into patterns today. Now, for those of you who have not used patterns, they are a productivity tool, bar none. Very simple patterns, very common patterns like linear and circular should be something that you're using quite commonly. Most people have something they can repeat, and you might consider mirroring to be a pattern type of a feature as well, although we're not going to get into that type of a thing. But linear and circular patterns really just scratch the surface. We get into other more complex things. Table-driven patterns, I'm not really going to show that, but it's very similar to a sketch-driven pattern. But even 3D types of patterns. Very, very nice tangencies, the way they follow curves. And then some things we've added in the last couple of releases here, these variable patterns. Whether it's just varying dimensions of features during the pattern, or using a table to drive these things. So we'll show you some fantastic things with those. And again, we're recording this, so if you need any of these files or would like any examples after the fact, just get a hold of me. I'll show my email address on the last slide. So let's go ahead and just start off with the most common, which is going to be a basic linear pattern. Now, I am not a death by PowerPoint guy, so we're going to get into SOLIDWORKS directly here. The basis for a pattern is pretty simple. Let me just go ahead and create a simple feature here. We can choose to either extrude this or cut it. I'm just going to go ahead and extrude this feature up. So we use a little bit of Instant 3D here and grab that sketch and pull this out. So basically what we're getting now is a single instance of an item. There's a pull down up at the top. Any of our flyout menus are going to have multiple pattern tools to it, of course. One of the things I like to do for situations like this, though, is I like to go ahead and make my own tabs. If you weren't aware of this, you can right-click on your tabs and say Customize, create a new tab, put any buttons on there that you want. So if you'd like to change the interface up so you have a single tab that has everything you use in a day, feel free to go ahead and do that. It's just a right-click Customize, and that gets you into the ability to add a new tab. So real simple to do. So with this, we're going to go ahead and start with a basic linear pattern. Now, with linear patterns, it's real simple. You define directions with some linear entity, whether it's an edge, a sketch entity, those kinds of things work pretty well. So just by selecting each of these edges, you'll notice we're grabbing different directions, and then the feature to pattern is going to instantly give you a preview. So as we start to change the spacings and the number of instances of this feature, obviously we're going to get a preview. Now, if we start to update the second direction here as well with an individual instance or multiple instances, we want to make sure the directions are proper, so the tiny buttons here will allow you to control each of those. And of course, by adding additional instances, you'll get a nice preview of each of those. Now, one of the keys to this also is the ability to be a little bit more fluid with patterns like this. A pattern like this one's going to give me kind of what you'd expect, all entities in both directions. A couple of the features I really like to show on this one, since everybody's probably touched this one at least once, is one of these options down here that allows us to pattern the seed only. This is very effective, especially when you're doing a pattern that goes in opposing directions. So if we're using the same edge to go one way and then that same edge to go the opposite way, effectively patterning from the middle, you'd want to just pattern the seed. Because otherwise you'd end up actually patterning the pattern over top of itself if the instances and the spacing are identical. And that can lead to some downstream issues that we have with some other patterns I'll show you later. But by patterning the seed only, you're going to get a pattern that looks more like this. So in this case, only the extrude is the feature that gets patterned. Now, as we edit this, there's another option that kind of meets it in the middle here if we pattern everything. And sorry, the preview is the same color as the part here. But instances to skip helps a lot in this case. Now, it activates a bunch of magenta dots, which is very similar to what you might see during weldments and sheet metal. These indicate that you can individually action on any of these locations. And when we're talking about patterns, we're essentially talking about the ability to instance skip or select those dots and basically select or remove individual instances as that pattern happens. So it's a real easy thing to take care of. And of course, it gives you a little bit more fine tuning when it comes to a pattern that's more or less equal in each direction, but there's a little bit of wiggle room in the middle for some other feature that you might run into. So that's some of the basics there. Now to take this to the next level, I have a linear rail here, and this is an example I like to show because it shows you how to make a pattern that's going to really kind of change when the geometry changes. Right now we've got a pattern of roughly 18 to 20 holes, and one of the issues with cuts is if you go ahead and take the part and make it smaller, so in this case it's too small to be cut, cut features then start to error out because they no longer have geometry to actually cut away. Now when we deal with these kinds of things, of course by editing this feature, I've had some really fun stuff here happening with previews in Windows 10 as well, so you'll see me deal with that. But the pattern itself is actually going off the part. Well, instead of changing the spacings and the number of instances so that it can fit on the part, one of the things we added last year in SOLIDWORKS 2015 was this thing called an up to reference. So instead of just indicating the spacing and the number of instances that you want, the up to allows you, much like an up to end condition on an extrude, actually reference a piece of geometry and limit where that pattern actually falls. So if I say up to and then select a point on this end face, essentially that end point is now the distance controller. And what happens with that is as we go ahead and start extending this rail out a little bit, you'll start to see that as we get long enough, it'll add additional instances of that hole as we get enough stock left. Okay, so that's pretty cool right there. Now, one of the things that really allows you to, again, get control of this is this issue where we have enough geometry for a hole to pop up, but it really pops up in essentially a half section when there's exactly 60 millimeters there. So by editing this linear feature, we've also got a neat little thing here that allows us to then give it an offset distance. So in this case, if I want to have not only the spacing between the holes of 60, but also a little bit of stock, you can type in the distance that you want. And then once you have your 60 plus the additional 25 of stock is only when that hole is going to appear. So now when it gets a little bit longer, it's going to go ahead and then start picking up that feature. So that's going to be something that is going to be constant spacing variable instances. Now we can also change that up a little bit, and instead of that being set to that constant spacing, we can also just give it a discrete number of instances. So in this case, if we wanted to have specifically 20 holes, this is going to be a difference where as I start to change the size of this feature, the number of holes is going to stay constant, but now the spacing will update as a result of the geometry change. Okay, so it's pretty smart. We used to do this with equations. Equations with the overall length chopping off the stock divided by the number of instances minus 1, essentially is how that was done before. So a pretty nifty way to deal with that. Now getting a little deeper on this, I want to show you some circular pattern stuff. Just as easy, but there's a neat end condition that I want to show you here that can up your performance in patterns as well. Now I'm not going to show you the threads that we've got on this 3-step drill, but that's a circular pattern where we basically swept a feature and then patterned that 3 times around the axis there to give us 3 flutes. What I am going to show on this one though is going to be this little circular part that we've got here. Now to lay a little groundwork here, I've created an extrude that goes up to a plane that's on an angle. Now when you're actually doing a circular pattern, real simple thing, go ahead and select the features that you want to pattern, and then for the reference, you can use an edge, an axis, or a cylindrical face or edge, and that will go ahead and start your preview. The key to this one here though is this thing called geometry pattern. Anybody ever use geometry pattern? Okay, you should if you can. Essentially this is going to be the performance setting for you. Now, I want to show you this as a performance setting, but I also want to show you the behavior that it exhibits. When you do a geometry pattern, it's not calculating the end condition of each individual instance. So essentially, the preview that we get right here is exactly the preview that you're going to get for your solid feature. But what it does is it patterns the body or the absence of the body if it happens to be a cut. But it does very little calculation other than the number of instances that are there. When you make a pattern, geometry pattern is typically off by default. Now, my preview didn't change. But what it does is it calculates every single instance. So if you have tread plate where you're going to have 50 holes by 2000, each instance will now be calculated. And the result of that gives you this. So that's what you want to keep in mind when you're doing patterns. And this is any pattern, not just linear patterns, but the circular really shows this one in a little bit more of an effective way. So if you want better performance, try geometry pattern. If it says you can't do it, just turn it off and the other one will work. But give it a shot either way. So that'll give you a lot more capabilities and again, better performance with those kinds of things. Sketch-driven patterns are also fairly basic, but you just drive those with a series of points, much like you would if you're creating a series of holes using the hole wizard. So back into SOLIDWORKS here, if we're going to go ahead and use these types of features, let's go ahead and grab that one. All I have here is just a basic number of points. Now, to really run through this, let me just sketch a feature. It doesn't really matter where it is. The offsets are basically going to be constant. But with something like this, we're just going to create something for visual sake. So now that we've got this item here, under our pattern tools, we'll go ahead and use sketch-driven pattern. The inputs are very simple. Once again, I have a sketch that's a series of points, and then I have a feature, features, or faces or bodies. We can go ahead and pattern those, and they will be at that very odd spacing. The key to this one, though, and for downstream usage, is that the sketch drives the whole thing, number of instances and positioning. So if you do go back into that sketch and edit the feature, just by adding additional points anywhere that you'd like, or by taking points and either moving them or changing dimensions, that's all going to update the number of instances that show up in that pattern. Yes?
How do you control that point that goes to the sketch?
Which one? The point, these points here?
Well, on the slot, there are 3 points.
Mm-hmm.
Middle point and the 2 end point.
Mm-hmm.
So which one, how do you pick that?
Oh, well, the way that I created this one happened to be the, oh, that was a new sketch there, excuse me. The way that I created this one happened to be just by using the slot tool where I snapped it right to the center.
So if I want to go snap to the right-hand side,
Mm-hmm.
how do you do that?
Oh, yeah, that would just be by drawing this feature differently. So if that's going to be where the centroid of that point is, then what you're going to see is that that's going to be the exact same offset for every individual instance here. So they're all going to be peppered along that same feature the same way. So it's essentially where you position it relative to the sketch points that are active there.
Oh, so the point that you want to snap and the orientation you want to...
Right. You want that first feature to be that way, and then everything else is just going to be basically like hole wizard holes, essentially. So hole wizard holes being a revolve, they're all going to be right on the center no matter what you do. This one here, you just want to have that a little bit more relative. So there's table-driven patterns as well, which would be a text file, XY points essentially, because it's a 2D type of an entity. Works very similar to this. Sorry, I'm talking fast again. The fill pattern is where we start to get a little bit more exotic. Now this allows us to use essentially linear pattern features, but it really gets a little bit deeper than that. But to contain this pattern within a given location. So what we're showing up in the corner there is I just made an elliptical sketch on a sheet metal part, popped a hole in there, and then did a fill pattern. And what it does is it patterns directly within the boundary that we've determined. Now that boundary can be a few different things. It can be just a sketch, as I'm using here. It can be a face. It can be split lines used to split a face, which would effectively be a sketch at that point. So all of those types of things are available. But what it does is it keeps the distances and the offsets within the actual feature itself that we've sketched. So here I've got a circle that's actually inside this hole, inside this kind of kidney-shaped spline sketch. When you go ahead and use the fill pattern, essentially there's 2 ways to deal with this. You select the boundary no matter what. This can or doesn't have to be a split line. Once again, I'm just going to leave it as a sketch. But you can choose to go ahead and use a selected feature if you'd like. Now, a selected feature would actually be discretely selecting this hole. So that's the important part about that. Once you start to deal with that and give it an orientation, which I'm going to use the bottom edge, it will then start to populate within this given boundary. Now, the way it populates is everything to do with these settings up here in the top. So if I want to start in the middle and then spiral out from this, we're going to change some of our spacing so we get a little bit more of a dense population in there. The kidney shape is sort of killing this just a little bit. But as I make this a little bit smaller, this value right here called the offset is actually keeping a margin between the outside of this pattern and the actual pattern itself. So as I start to lower that number, you'll start to see more instances appear as they start to skirt the edge of our boundary. Now, if you start to make that 0, if the offsets are proper based on these other angles and spacings, you'll start to get these things snuggling right up to the edge. But you can see that as we start to change that margin, it gives us that offset, that controlled feature. Now, we can do this, and of course the sketch drives everything, just as everything else does. So if I start changing that sketch, what we'll now see upon a rebuild is that it will repopulate that area. So earpieces on a cell phone or grills or vents or any of the types of things. It's a really nice, effective way to deal with this without making a real linear or circular pattern and then skipping instances. So kind of another way to skin that cat. When we're dealing with this though, I had actually drawn a circular feature here and cut it. Now that's not necessary really. We've actually got this thing down here called create a seed cut. What that will do is give you some basic primitive shapes that SOLIDWORKS will determine. So if you want to go ahead and use a circle or a square instead, change the geometry of that square, and then again start to tweak the offsets that we get here. Those kinds of things are then going to go ahead and use these primitive features instead of the created feature that I made. But it's kind of a library or just a repository of the most common items that you'd want to use. Kind of along the lines that SOLIDWORKS did this year with the sweep feature, where we have a feature where you can just say circular profile instead of actually creating a sketch for that, since it's the most common type. But these are pretty interesting nonetheless. When you start to get more exotic, now you start to get into curve-driven patterns. These are patterns that just don't fall into these very generic boxes. I'm going to show a couple of these. We've got this knob in the corner here, and then this oil pan that I created that's got obviously an extremely odd border around the edge of this. So the oil pan is going to be the first one I start with here because that would be a 2D curve-driven pattern. So we'll begin with that one. The previews are something you're going to want to rely on with these kinds of things. So when we get into our pattern tools here, once again, we're going to use curve-driven pattern. And many of these features are also available inside of the assembly as well. So when we're dealing with those kinds of things, you're dealing with either component patterns that we're doing, or you're dealing with deriving patterns from existing feature patterns. But the curve-driven pattern works in both of those places. Now the curve that I want to use, I actually haven't created yet. I've got one there that's hidden, but I want to show you how you can get to that as well. Something like this is pretty simple. I'm just going to right-click on an edge. You got a simple selection here called Select Tangency. As long as that edge blends smooth with all the other edges around the part, that's going to go ahead and select them in sequence. Under your Features toolbar and Curves, you can go ahead and create something called a composite curve. And that can be a combination of any of the feature edges, part edges, sketches, or other types of curves like helicoils. You can combine all those together to form one individual curve. Now with that curve selected, when we go ahead and do this curve-driven pattern, all we have to do now is go ahead and fill in the feature that we want. We can either select the keyhole that I've got out here graphically, or we can go ahead and select that thing normal. So usually what you get in your offset is something like this. Here's your preview, and you sort of see how things are staying in their relative position to the right offset that we get off of this path. The other thing that you see from the preview is that all the keyways are in exactly the same orientation. Now, as you know from a lot of the features in SOLIDWORKS, things are typically just a radio button or a checkbox away from working the way you want to. So always experiment with things over here in the Property Manager. Yeah, there's a lot of giggling going on with that, but you guys know what we're talking about. So over here, there's two that I like on this one quite a bit. Tangent to curve is the second one that I'm going to use. But align to seed versus tangent to curve is basically going to change this and make the orientation now follow at least the path direction as it serpentines around this odd spacing. The transform method here, doing offset, will actually keep it offset inward versus offset to the same direction relative to that curve. So those are the two that you really want. If I go back to align to seed, you'll see again that they're in the same orientation, but tangent to curve is going to make them, as they're all walking around a path, equal spaced around this part. So this one here is quite nifty. And once again, something you really can't even create by trying to cobble together linear patterns and skipping instances or anything like that. So very difficult to do in any other circumstance in this respect. When you start to take this to the 3D method, then we start to get a little bit deeper when it comes to this little knob that I want to use on this one. Actually, I'm not finding my knob now that I'm looking for it. So we'll go ahead and locate that. That's the one we want, I think. All right. So we've got this piece right here. And the reason I wanted to get 3D on this is because those tangencies are emphasized now that we're not just talking about a 2D planar orientation. The curve that we're going to follow on this one really took place before we added this fillet. So just to really demystify this for you, since we're more of a learning environment, this is a 3D sketch converted edge. Could also be a composite curve of that edge. But one way or another, we have this curve right up here that was taken off of the existing geometry and then a fillet in order to go ahead and offset that a little bit. It's the same process, though, in exactly the same tool. When you go to your curve-driven pattern here, we're still doing the same inputs. So I'll select the 3D curve as my pattern, curve, the actual feature we'll select on screen, and we're going to get a little, again, fighting of the previews that we've got here. So I'm going to try and get that to go. So again, we've got some orientation issues here. You can see that they're all slanting down and to the right. So on this side of the part, of course, they're going to be piercing the part as opposed to being tangent on the edge of the part as we see over here. And yeah, the previews are really having a problem on this one. But one of the orientations that we need on this one, same with align to seed and tangent to curve and offset and transform, is that's going to allow you to change the position of each of these features. But there's this other thing called a face normal. Now the face normal is this really odd face that's more of a slotted or elliptical shape going around the part here. And when you select the face normal and click this face, that's going to give it the orientation that it needs to position these in the proper position. So now you see they all now slide as if they're rolling around this part, following the curve, but following the direction of the face, more importantly, relative to the way the initial seed feature follows that face. So the final result of this one, again with a few checkboxes and a couple more inputs, is going to give you this really fantastic looking feature that follows that 3D shape and the face that it needs to map to. So quite nifty on that one. I won't show you the creation of this one, but the baseball is one that I really like to show as well. This is just a simple tie or a stitch that's been placed on a plane at a point tangent to that face. And then all we're doing is using a nice little curve that was created by actually taking a very simple horseshoe-shaped sketch and using that to make a split line. So if we go ahead and roll back a little bit, you can see how that takes place. We made a sketch, little horseshoe shape, and then the split line in both directions is going to give you the thread path, or the tie path. Pretty interesting. So once again, little stitch extruded out there, and then that stitch patterned in 3D space tangent to one of these two faces. So quite cool there. Any questions? Yeah.
We make speaker grills and have slats, and as they get closer to the edge of the border, they get smaller.
Changes this distance, yeah.
The slats itself get smaller.
Yeah, I don't have an example worked up for that, but the next couple of features I show you might be the key to your situation there, which really allows for a lot of variation to be injected into this process. So hold that question for just a little bit more. This is another one that I think this is the phone I'm looking for. Yeah, so that's got some ridges on the back. It's a pretty archaic little phone compared to today's standards, but you get the idea. 3D curve following the orientation in that position. So going a little deeper on this one, we get into this thing we call the variable pattern. Now this allows us to not just pattern the seed as is, but to change the seed as it's patterning in really any way that we want to based on dimensions of the feature or other inputs around there. Now there's two different ways to do this. Back in 2013, we had a nice little demonstration file here that was just simply the ability to use run-of-the-mill linear patterns and vary the dimensions as you patterned. But then we started getting into 3D things. These are going to be created in much of the way that you create a design table-based part, so configurations. But it's a table-driven type of a pattern, which really opens up a wealth of other opportunities when it comes to changing orientation, shape, and so on. So let me start with the basic muffler here for starters, and then we'll get a little bit deeper into this. So each of the features that we've got here were created by using these patterns. What we've got up here is just a basic linear pattern. There's a slotted feature here, which is our seed, which is tiny. And then as it moves to the left here, it simply expands. Now it's expanding, but we're also varying the spacing in between because obviously the gap between dissimilar sized features is constant. So it's a real simple thing to pull off. Now down here on the bottom, we're actually creating a pattern here by using a seed feature in the middle. And as it's going in opposing directions, it's getting slightly smaller. So constant spacing, but variable size of the feature itself. So I want to show you how that's done on this side feature right up here. So another slot. Now we're not using a different tool for this. I just want to show you some other options in the common tools that are already there. So this one here is actually the basic linear pattern. We set it up the same way. I've selected my feature already. Now I just need to give it a direction, which I'll use a simple linear edge for that. And we'll just do 5 of these at 30 for right now. So let's drop that down a touch. Now down here at the bottom, way near the bottom, actually right at the bottom, there's a checkbox called Instances to Vary. And when you click that checkbox, you get additional interface capabilities down here. Now what it assumes is that the spacing is probably one of the things you're going to vary. So it's a default right here. So what I can do is say with each subsequent instance, I want to vary that spacing by 7 more. That's going to update our preview so we get 30, 37, 44, and then continuing on. But then what we can also do is click in this box where it says choose feature dimensions to vary. And that can be any of the dimensions used on the feature itself. So once I select the slot width and the slot length, they actually become inputs on the flyout tool tab here, as well as in the property manager. So what we're going to do on this one is we're going to take the length of 80. With each individual instance that adds to it, I want to add 40 millimeters to each. And again, dealing with the previews here, let's click over to full preview. So now by adding 40, each of them grows 40 as they go. And then I also want to go ahead and change the width by 4 with each individual. So now each of them gaps up a little bit more with each individual instance. Now down here at the bottom, of course, we built this as an example. It's not going to work for every situation, but those little magenta dots there are the savior to this type of a situation. They're instances to skip if you're doing a run-of-the-mill pattern. But in this situation, when you click on that dot, you can either skip the instance or modify the instance, and then it becomes individually editable. So now in this case, the overall length as it calculates up has now transformed to 240. I can discretely type in any value that I want for that instance and override the entire situation. So 90th percentile gets you there, the other massaging will get you the rest of the way. And if all else fails, extrude over it or skip it and just make one feature in there. So great way to make those patterns. But that is basic linear pattern, basic pattern features in any instance where you can skip those or vary those instances. So pretty cool stuff on that. What we added in SOLIDWORKS 2015 and it's really gotten a lot more sophisticated is the ability to go ahead and create something that's now going to be driven more by a table. So let me go ahead and show you this one. This is a little pattern feature here where it's really got actually a lot more going for it. Ingenious ways of modeling can really save yourself a lot of time and create some very complex but really simple features as they go. Down here what we've got to show you what this feature is we've got a pattern that starts by using this seed feature. It's effectively a slotted sketch extruded out with a little fillet around the edge. And then we used a surface to hack it off that's offset from this compound face here. But the key is the fact that this is more of an S shape. It's more of a spline type of a shape here. It was built on a plane that was created at a point. Let me get the right planes. You can use 3D Sketch and you can put a point on any face. By default, that point goes coincident to the face. You can then go ahead and insert a plane tangent to the face, coincident to the point, which means any plane that we put in will then sit in this really nice little spot here, right along the edge. But the important part is that as we pattern that and it moves over here, the tilting of that plane will stay tangent to that face as it goes. Now using this tool, we're not only going to pattern the slot and the fillet, but we're also going to pattern that sketched point and the plane as part of it. And all of that is really going to build up to be a feature that actually follows the contour of this face. So enough of the hand puppets, let me get into this. So by editing the feature, what I want to show you here first of all is the input. You select the feature itself, so the grip, which is just the extrude we've renamed, and then the fillet itself that's at the base. And then the reference geometry, which is the sketch point, the plane, and then grip position. I'm not sure what that is. I think it's another plane offset. Using this tool here, which is called the variable pattern, we actually use a table to create this. Now the table we have right now is very simple. We have one additional instance. If I update the preview, that instance is slightly below. It's offset a little to the left, 2 millimeters, and in this case it's 17 millimeters away. But it's also larger than the original. The original is 18 millimeters, where the new one is 24. Now by tweaking any of these numbers, you'll be able to see that the preview updates, which in this case we're going to slide that slot over to the right just a little bit. Now down here at the bottom, you can add additional rows if you want. Whatever number is typed here when you click this button, it's going to add an additional to it. Now with this one, we can do a lot of things. We can type in negative numbers, which is cool. Negative numbers is going to give me, bless you, another one in the opposite direction. If we change the width on that one, of course, that's going to go ahead and modify that individual instance. Now the one on top will also get a little larger. Well, this can be tedious if you've got a lot of work to do. So this tool is also able to use spreadsheets as the driving feature. What you'd do is you'd set up this part of it right here. And then with this button, we'd go ahead and export that to Excel. That way you'd have the proper format, the proper column headings with the proper dimensional values and feature names. Then you go ahead and modify it in Excel and import it back from Excel once it's all said and done. And that gives you the ability to go ahead and use things like concatenation and other formulas that are a little bit more powerful than the way this table works. So I can use a couple of different ones here. I want to use this one called offset. And it's basically going to start moving these things left and right. It's going to change the widths of them and then of course space a few above and below. And by importing that into this table, that allows me to then update my preview, which is now going to give you a really fantastic result here that actually is going to follow in a very odd pattern. One individual pattern feature. But like I said, we're also patterning that point coincident to the face and then the plane tangent to that face, which means this pattern actually follows the shape of that face. So it's a really effective way to get some phenomenal geometry without a lot of extra work. Previous releases, of course, this would have taken an individual instance basically for everything that you've got here. So that creates a really awesome pattern with a single feature in the feature tree, which is quite cool. Now that gets a little bit deeper depending on what we want to show. This is one I showed a couple of years ago, these football spikes. But it's the same kind of thing. It's a variable surface here, very organic shape. And all we're doing is taking one original spike down here and patterning that distances to the up direction, to the right, and then tilting an angle so that you see each of those are in a different position. We started with 24, all the spikes on the heel are 24, and these are all 18. But it gives you the ability to then go ahead and take individual instances, yes please, and we'll go ahead and modify the position of a spike. And as that moves down, what I've done here is effectively edited the table. So that cell in the table will now say 150 instead of 200. And of course I grabbed the wrong dimension for the wrong feature there, so that's going to look really ugly. But we'll go ahead and do the one in the middle here as well. And when it pulls it down and towards us, it basically tilts it the same angle tangent to that face still. So kind of hard to see on the example, but it is following the contour much like those slots just did on the grip handle that we've got there. So really cool stuff there. Last one I'll show you here, this remote cover is pretty good as well. Believe it or not, this is one feature and one pattern. Take a look at this variable pattern. Each one of those, yes it is, was made by using a single table. So when I go ahead and show you the table here and just simply update the preview, this one set of columns is taking the one slot and it's patterning it in distances, directions, tilting it, changing dimensions, and it really is only about 5 columns within this pattern. It's worth the wait when it comes to the preview updating here. There it goes. So that is one pattern feature, but really this is the entire table. You're seeing the whole thing. There's 5 dimensions being controlled on this, which is X, Y position, width, angle in some cases, so we're getting slots in different directions. But that is a single feature creating absolutely every single one of those holes. So I find that phenomenal. Great example file though, something you can really draw upon for creating these types of features. Yikes, got 5 more minutes here. What a lot of people I find, and these are even seasoned users, don't realize is that when you make patterns at the part level, you can leverage those patterns at the assembly level. Anybody not know that? I should have done the other way. I want to get everybody to raise their hands once. So if you already know this, then I'm really just telling you what you already know, but I might even show you something here that you might not be aware of. So the first thing we're going to get into is this cover that I've got up here, because it's actually 3 different examples of the same type of thing. So when we get into, let's do the entire assembly. So when we get into this assembly right here, what's interesting about this is by making the pattern in the part, you've now got a single one-stop shopping edit. You edit the feature in the part, and everything else, right down to the bill of materials on the drawing, will update the instance count of other features referencing it. So here I have a simple hole wizard hole set. So a few different ways that we've created this. This is just a hole wizard hole counter bore and just 4 points that we've selected. So actually no pattern there. But in an assembly, you go onto your assembly pull down and we've got our linear component pattern. Now this thing got renamed. It's called Pattern-Driven Pattern. We did that in 2015. It used to be called Feature-Driven Pattern. So just in case you're not sure what that is, it is the exact same thing. But it's a pattern-driven pattern. It requires 2 very simple things. The components you want to pattern, which in this case is just one fastener, and then the feature that you want of the part to drive it. We'll just go ahead and select this. You'll see that it automatically populates those holes. Now, of course, if we go ahead and then edit the plate or edit this cover and change the hole pattern and add additional instances or change positions, those fasteners are going to move right along with it. I'll show you that actually in a future feature here. What I love about these features, and this is where you might add a little bit to your knowledge gap here, is that you don't have to be terribly conscious as to what the seed feature of these original patterns are. So in other words, if we take a look at this cover, I've got a hole pattern over here. It's a fill pattern. And if you look at this, we basically have, in this case, the seed feature being inside this hole. So I'll flush this out a little bit further. But that's a fill pattern like we just did on that previous example. By doing the pattern-driven pattern, once again, select the feature, select the actual hole pattern. Oop, not going to work there. Let's select the hole pattern. And then you automatically get a very nice preview of what each of those happens to be. So once again, leveraging what you've already done, and if the feature on the part changes, it trickles down all the way through the drawing. This pattern that we have around here, though, this is a curve-driven pattern. And the key to this one, if I go ahead and select it, is with the color coding, you can see that my fastener is not in the seed hole. You don't have to be aware of that. And that changed quite a while ago. You used to have to be that way. In this case, I'm doing exactly the same thing. Pattern-driven pattern, grabbing the component, and then selecting the pattern that I want to use. You can see that we've got a beautiful set of offsets there. So it doesn't matter what hole you actually originate that in, it's still going to give you the proper offsets to each of these pattern features. Now, to go the full direction on this one, I'm going to open this part up in its own window. We're going to do a little tiling. Oh, that's not going to look so good. Haha, let's do that a little different. I like to show these side by side, but let's just do these individually. So now when we get into the curve-driven pattern here, if we start to go ahead and start modifying things like instances, probably could have done this back in the assembly for a better effect. But if we go ahead and bump that up to 20, of course, what we're now going to get is additional holes around the edge. We toggle back over to the assembly file, and our holes are going to be populated with fasteners. So again, very easy to deal with that. and that works for any type of pattern within a feature. Let's go a little deeper on that one. Yeah, Peggy.
On when you're putting fasteners in, then of course you're only constraining the one, and then you're patterning that or whatever. So
Right.
what does that do to the size of your model then? Is it better to do it through a pattern or individual or?
Well, I mean, individuals, you're going to have to mate each one. And then if you increase the hole pattern, of course, you're going to have to add new fasteners to each of those holes. But more importantly, if you decrease the hole pattern, then you're going to have dangling parts with missing or broken mates. So this one here just rolls along fluidly the whole way. So if I go a little deeper on this one here, let's just use little breadcrumbs here just in case you guys want to learn some new stuff there. But let me edit this one here. I'm going to move this hole over to, or move this fastener over to that hole. So again, just to really emphasize this fact. Once that part's in place, we go ahead and do the same pattern-driven pattern. So my feature's over here. My pattern is any one of these other holes that we want to use. And once again, very easily puts those in place. So pretty nifty way to be able to deal with that kind of stuff. One more example of this, I like to show this one as well. It's a little deeper on the chain system that we've got here. But this is a neat little 3D type of a thing where we're not just dealing with individual parts. In this case, we're actually going even deeper into assemblies. But now we're talking a curve-driven pattern and or a pattern-driven pattern. So in this case, I want to show you both at the assembly level. Here I'm going to do a basic curve-driven pattern. So once again, the same that you would see back in the part file. The curve that I'm going to use is a 2D sketch in this case. And this sketch happens to go the exact same direction as these existing chain links that you see here. The components to pattern in this case are going to fill out this hole. So once I go ahead and start selecting those pieces, you'll start to see the preview that we're going to get. Now I'm going to do 24 of these guys, and we're going to space them out at 9, and then you'll start to see their positions. But once again, as we start to turn the corner, they're all aligned to the same position as the seed feature. So keep in mind, tangent to curve is your friend in these cases. It's going to tilt it, it's going to follow the curve, it's going to keep that position appropriately as it goes. Now I'm using a curve to drive apart like these pieces of the chain. Well, once that's done, I can use the pattern that we've just done now to drive the rest of the other components that we might want to pattern. This one's a little heavier than just what you see on the screen, by the way, so that's why we're getting a little bit of rebuild time. But when we then go ahead and do a pattern-driven pattern, now we're basically saying I want to use this pattern to then go ahead and drive components to pattern. Let's do that different. Let's grab the entire subassembly up here. So we're going to do this carrier, and then we're going to drive it by using this set of pattern parts. So once again, they follow all of the settings, the tangencies, the offsets, the distances, and everything. And again, this is a very large assembly, not something the size that you might have just seen from that zoom position. But everything being associative, we start to change that sketch and make it bigger, change the positions of the sprockets, essentially, which would then change the sketch, changes the pattern, number of links, number of carriers. It's all a very cascading element when you start by driving it at the lowest feature, which is the sketch driven by the positions of these sprockets. So very, very cool stuff there. With SOLIDWORKS 20, I'm starting to lose track of the versions we do these in. So this was around SOLIDWORKS 2014. We went to the ability to then do these kinds of patterns, not just in a visual representation, but also something that actually performed very well with just basic drag and drop types of rebuilds. And that was something called the chain component pattern. Now to show you what we're talking about here, we're basically getting into a few different examples of things that look like what we see here, only this was done in a previous release using basic pattern features. What it didn't do was this kind of stuff. Okay, so that is high performance drag and drop rebuild, which you really don't get by using a feature. Mates are what's going to make that type of a thing happen in most cases. But by grabbing on this link and dragging it around, you can see that I can pull it around this very complex path and have very fluid motion driving this. Now what's driving the position is a gear mate. So the 3 sprockets there have a gear mate. Their position or their rotation ratio is going to be based on the edges that you select. So essentially selecting the outside diameters of each is going to have them rotate at the proper ratios relative to each other. But to create something like this, what we're really doing is taking a bunch of other things together and combining those. So I've got this little one right here. That's my finished version, excuse me. We'll get out of that one. This last gantry, though, is the piece that I want to show on this one as an example. And this is something that a lot of customers use here, these energy chains. You've got overhead gantries. They've got these racks that have a lot of cables in them. And as they slide back and forth, we want those pieces to physically move. Now, Fanuc Robotics has been a company, a customer of ours since 1997, and this is all over their stuff. So I know you've seen these in different places. And one of the guys there wrote a program over the years to make that kind of thing happen. So it was really pleasant to see this within the software. But let me show you exactly how this thing works and the steps it takes to make this thing tick. So the 4 parts that I'm dealing with here are all sort of unique. This part down here is fixed. We got to quickly do this one. This one's got all of its degrees of freedom. And then this one up here can rotate left and right, but it's basically planar or parallel to the top plane. So this tool here is its own tool. It's at the bottom here and it's called a chain component pattern. So the way you deal with this is very simple. The path is going to be what you follow, so like a curve-driven pattern. And when you see the selection manager, you want to take note of that, because if I selected something on screen right now, I'm only getting that top edge. I'm not getting the entire curve. But the selection manager allows me to, on the fly, select open loops, closed loops, or random selections that group together. When you select an open loop and I grab that edge, it grabs all connected entities as one single entity. So that's an important thing. Now I pick the thing that I want to pattern, which is going to be this piece of the sprocket. Now its position, this piece of the chain. The position is relative to what we select next, and that's in this pivot hole. We'll just grab the inside pivot. And then one other piece of alignment here has to do with a plane that's in the center of this part. When you select the plane alignment, it'll take this part and preview it right down there on that chain path. Now what I can do here is fill this in with a bunch of instances. We can change the spacing on this one, which is pretty ridiculous right now. Let's make that like 20. 20 is even ridiculous. Let's make it 50. So we get this spacing in here, but as you start to fill these things in, you're getting some behavior much like what we've shown in previous instances. As the seed feature changes, everything else relative to that actually changes. Now this sketch here is part of a part that's actually moving right now, so I'm going to fix that so it doesn't move. But you see how these things follow. Now by editing that pattern, there's a couple of different ways to deal with this. We can do this thing called a distance linkage, which then requires us to pick an additional pivot point here, so the front and the back of this piece of chain. By putting that in place, we now get a little bit more like what we're looking for, where these things follow the path, but they're still not connected to each other. Now in situations that we deal with here, where we're dealing with the way an energy chain is designed, is it's designed that it fits into itself. So the back half of this one fits into the front half of the next one. When you're dealing with either this situation or a bike chain where it has big link, small link, and they alternate, that's where you use this last option here called connected linkage. Now what that automatically does is, because it knows the first and second pivot points, it will up that pattern relative, and then additional instances will simply get added. Now if you have that small chain piece, you just simply turn on chain group 2, pick that second part, first hole, second hole, and then it will know how to add and alternate those properly. So in this case here, we're just going to add additional instances to the path. They know where the beginning and the end of each of them are, so they all fit together properly, and then that's going to give us a little bit more like what we're looking for. So a little smart mate to finish this up. We're just going to drag these pieces together to add that concentric and coincident mate, and then same thing over here. Let's just go ahead and alt, pick and drag, and there is our concentric. Now by taking this part and floating it again, what we now have is this sketch can move back and forth. So even though you don't typically see it, it's following this part because the sketch allows the part to slide left and right. But typically in an assembly, you take that sketch and hide it, and the effect would still be the same. You just wouldn't visually see that piece. The rub to this is that if the sketch has to rebuild, it doesn't work. Okay? When you move it and hit rebuild, it will update. So that's cool, but it doesn't work through drag and drop. Now, if you're ingenious to this part of it, you might know that SOLIDWORKS animation rebuilds every single frame that you make. So if I really want this effect to work, we can do a motion study, kick on SOLIDWORKS animation, which I'm going to move up here for 1 second. And if I simply start an animation where I have a part, for example, like this part right here, maybe I want to go ahead and take that part and put a little key point right here. So I'll place a key. Then we'll move over 4 seconds, move that part to a different position, and then auto keys will give me a new key. Now when we actually calculate this one, watch what happens in our path here. It starts to move. Now we got this red area. See, it lets go. However, the second time through, it calculates. And the animation will have the fluid movement that you're looking for. So that's a pretty cool little add-on to those kinds of things. But any animation we do in SOLIDWORKS rebuilds every single frame. So the spring examples that you see where parts are moving and the length of the spring is relative to that movement, whenever you're animating, those rebuilds will pick up that type of a situation. All right. So thank you for that rapid fire session. I hope you enjoyed that. Thank you very much.